Okay, so we're talking about exponents and negative powers, okay? Now, just to be clear, okay, if we have an exponent, alright, we'll say x to the negative 2. Alright, anytime you have a negative power, that represents a fraction. So x over negative 2 is really 1 over x squared. Okay? So, alright, let's talk about when you multiply two exponents, right? We know that when we multiply two exponents, that what? We add the two powers, right? This is all review. So again, quickly, this is going to be 2 to the negative 2 plus negative 7. That's negative 2 plus negative 7. That's just negative 2 minus 7, right? Because plus and minus equals negative. So that's equal to 2 to the negative 9, right? Because negative 2 minus 7 is negative 9. Alright? If you have to rewrite that as a fraction, then it's going to be 1 over 2 over 9. And then you can try to work out what's 2 times 2 times 2 times 2. But I don't think you're going to really find a lot of these kind of problems. We have big powers like that. But I just want to get to the point that if you have a negative power, you have a fraction. Okay? Alright, so let's look at this problem right here. Now we're going to look at quotients, right? Dividing. Now here's a general rule when it comes to if you have negative powers in the quotients, okay? So if you have a negative power in the bottom, which is a denominator, you can rewrite that as a positive power, but you have to bring this exponent to the top, okay? Vice versa, okay? On the other hand, if you have, right, we know this, right? Because if you have a negative power on the top, then you have to bring it to the bottom, right? And it becomes a positive power. So this is what I mean. So example, if you look at this power, if we rewrite this, right, this is what I want you to do. If you have a negative power, I want you to try to convert this into a problem that would have positive powers. Alright? So what I would do is, I'd first draw a fraction line, alright? Then just copy down the stuff that's not affected, so it's these 4 and 2, right? So just write 4 and 2, right? But we have to maybe worry about the b's, right? Because we have a negative b. Alright, let's look at b cubed. Is that going to go down? No, it's positive, right? It just stays there. What about the bottom b? Well, the bottom b we have negative 4, so if we want to rewrite that as a positive power, we have to bring it b negative 4 up here, and it would become a b to the positive 4, right? So then let's just copy down b cubed, and then b, so if you have b to negative 4 in the denominator, we can rewrite that as b to the 4th in the numerator. Okay? So now, all we really have is in the bottom is just a number, fraction, right? A number in the denominator, and then the top we can multiply these two b's, right? These are just multiplying exponents. So let's first cancel out the 4 and the 2. So the 2 cancels, that becomes 1, the 4 becomes 2, right? Because 2 goes in 2 and 2 goes into 4 2 times. Alright, then let's combine the b's together, okay? So b cubed plus times b to the 4th is, so that's going to be 2 times b to the 3 plus 4 is b to the 7th, okay? Now, do we have any in the bottom? We'll just have 1, so we don't necessarily have to write it in fractions, so this would just be the final answer right there. Alright. What about this one? Okay, this is kind of a special case, isn't it? So we have a negative exponent on top and a negative exponent on the bottom. So that means if you want to rewrite this problem as with all positive exponents, that means this k to negative 1 will go to the bottom, just become k to the 1, and this k to negative 2 will come to the top and just become k to k squared. And this 7 over 6, that we just leave it alone. These numbers alone, okay? So it becomes Alright, 7, and then copy down 6. Alright, so we're going to bring k to negative 2 to the top, so that's going to be k squared. And then we're going to bring k to negative 1 bottom. You can rewrite this k to the 1 or just k, but that doesn't matter. Okay. Now if you look here, you have to ask yourself, okay, we have a quotient, but you know, if we have two fractions, we can do cancellation, right? So we have k squared top, k1, alright, so k1 is going to cancel, alright, and then we're going to have top just 1k left over, right? Because when we're talking about cancellation, right, take the bigger power, subtract it from the lower power, and then you get k1 left over. Okay, so you get 7k to the 1. Okay, that's going to be the top part. Of course, k to the 1, we can just write as 7k, right? That's assume that 7k is 7k to the 1. What do we have in the bottom? 6. Alright? So the final answer would be 7k over 6. Alright, we can also do that with, you know, more than one term, right? So if we look at this problem here, what do we have here? Well, we've got m and n, right? We have two variables. But again, remember I said that we just have to, you know, compare or just do the problems, you know, with the respective variables. So if you look at the bottom, it has m's, right? Does it have n? No, it doesn't, right? So we don't have to worry about the n's. Alright. But anyhow, before we go there, we have to make sure we have to convert these to positive powers. -4, -4, right? So again, to do that, we bring the m to -4 to the bottom, and also the n to -4 to the bottom, okay? So what do you get here? We're going to get 4, so let me write the fraction. 4, okay, now if we bring, let's just rewrite the 4 at the bottom here too, right? Alright. Alright, so we have an m here. Alright, let's bring this m to the -4 to the bottom, okay? So that becomes m times m to the 4th, right? This n to -4, we can bring that to the bottom, right? It becomes n to the 4th. So we're going to have 4 over 4m times m to the 4th times n to the 4th, because we brought these negative powers down to the denominator. Okay, well, let's compare the numbers. Well, we can cancel these out, right? 4's cancel, they're both 1s. And then now we can combine these terms here. We have m times m to the 4th, right? So we can add or multiply these two exponents by just adding the powers, right? So we're going to have 1 over m to the 1 times m to the 4th is m to the 5th power. And then do you do anything to this n to the 4th power? We can't really do anything, right? So we just rewrite it. So that's what it becomes. 1 over n to the 5th, n to the 4th. Okay, finally, let's look at when we have negative powers, we're using the power properties, right? So again, the way it works is that you take the outer power and we distribute it to each individual part of the monomial, right? We distribute the -2 power to the 4m squared to -2 and then n to -2. So then this becomes 4 to the -2, right? Not 4 times -2, but 4 to the -2. And then here, m squared to -2. Okay, what we do is multiply the two numbers out, right? The two powers out, right? 2 times -2 is m to the -4. And then here we have n to the -2. Well, okay. So if you look here, we all have negative powers, right? So what we can do is we can just rewrite it right now as everything as a fraction. So remember that 4 to the -2 is really 1 over 4 squared, right? And then times, and then m to -4 is just really 1 over m to the 4th power times, and then n to the negative 2 power is just 1 over n squared, right? And then we can just multiply everything out respectively. So you have 1 over 4 squared. What's 4 times 4? 4 times 4 is 16 times m to the 4th times n squared. So again, when it comes to the power properties, okay, if you have a negative number like this, it becomes a fraction and you just multiply it out like regular fractions that we do, right? So if you look here at the denominators, right? Remember when we multiply fractions, we just multiply the numerators together. They're all just ones. And then we multiply the denominator together, right? And that's what you did. Okay, so next what I'm going to do, alright, is I'm going to give you several problems to do. I will work it out in the video, but what I want you to do is I want you to pause the video, alright, and then work out the problem, see if you get the right solution, okay? Okay, so now I want you to try these 3 problems, okay? They're very similar to the examples I did before, okay? Now, I want you to pause this video and then work out the problems, alright? I will work out this problem in the videos, but I don't want you to just look at the solution and think you're going to learn, alright? Honestly, if you do that, you're only cheating yourself, okay? You're only cheating yourself. So, pause the video, work out the problems, alright, and then see compared to what I have. I will tell you this, okay? These first 2 problems, alright? There's two ways of doing it, okay? There's the way that I showed you in the previous video, but then there's a thing that you can do using the property of quotients, okay? You know, when we have exponents, right? So try to do both, but if you find using the quotient kind of hard, then do it the other way where you flip the variables and then do the simplifying, okay? Okay, pause the video, and then after you're done, then I'll work out the problems. Okay, so let's work out the first problem, okay? So if we look here, okay, we have a fraction, or we call it quotient, right? So the first way I'm going to work out is the way that I just showed in the previous examples, where we're going to flip, alright, the negative exponents to become positive, right? So let's look at the top, alright, right here. We have a negative exponent. Do we have one at the bottom? No. Right, so that means that we're going to have to flip this, alright? So again, draw out your fraction line like this. Alright, let's copy the numbers first. 7. Alright, then let's focus on the x terms, okay? So look at this x and negative 2. That's going to come to the bottom, right? So we're going to have to write that in the bottom here. X squared times x cubed. So don't forget about that x cubed in the bottom. Okay, now we have 7 over x squared times x cubed. Alright, this is just merely, right, multiplying 2, alright, 2 exponents, right? So the rule is to add the 2 powers. So it becomes 7 over x squared plus x cubed is 2 plus 3, so it's x to the 5th power. Okay, now the alternate method, alright, is to take the 2 powers and then use a quotient rule. So whenever we divide 2 exponents like this, right, the same base, we subtract the 2 powers, right? So here we just copy the 7 over because that's not involved, right? Then it's going to be x to the negative 2 divided by x cubed, so it's going to be 7x to the minus 2 minus, right, because we're subtracting 3. So it becomes 7 to the x and negative 2 to the minus 3 power, right? So that equals 7 to x, what's negative 2 minus 3? Okay, that's going to be negative 5, right? Because when we have negative like that, we add the 2 numbers, you get a negative value. Well, let's compare this to that. Well, they're the same exact thing, aren't they? Because remember we said 7x, well, we said anything to the negative power is a fraction. So that's just going to be 7 over x to the 5th power. So you see how both ways work, okay? So you're gonna have to ask your teacher if you can do this method or if you can just do this method, but both ways are totally valid. Okay, let's do this one right here. Okay, let's look at the top, or at the numerator. Do we have any negative powers? We have surely this one here. What about the bottom? Okay, we don't. So we don't have to do anything to the bottom. Right, so we're going to have to do something to the top, right, this negative power. Right, so draw your fraction line. Okay, let's focus on the numbers here. 2 over 5. Okay, we're not going to do anything, so we just copy them. 2 over 5, okay? Now if you want to like make sure that, you know, keep track, you can just kind of like cross them out like that. Make sure you're done, okay? Alright, let's look at this x to the minus cube. Do we have any x's in the bottom? No, so we don't have to worry about copying over any x's. So again, if we want to make this to a positive power, we have to bring it down to the denominator, right? So that becomes 5x cubed, right? So we bring that x cubed down here to the denominator. Okay, that's done. Alright, we have y squared over y. Okay, we just copy those over, okay? So we have y squared over y. Okay, should put a little dot there. Okay, so now we can do simplification, right? Can we divide 2 over 5? Can't really do there. There's no other x's, so we can't cancel that out. Y's we can, right? Because we have y to the 1 over here. Okay, so we cross out the y, and then 2, subtract 1, so we have y to the 1, right? So what do we have left in the top? We have a 2 and a y over, in the bottom, we have 5x cubed, right in the bottom. Okay, finally let's look at this one. This one is, we use the power properties, right? So again, let's distribute to each one of these, alright, parts of the monomial. So, the negative 2 power is going to go to 8 to the negative 2, alright, and then we're going to get u, right, to the, okay, we're going to multiply 2 powers, so 4 times negative 2 is negative 8, u to the negative 8, and then we're going to have v to the 4th power times to the negative 2 power, so we're going to multiply those out too, so that's going to be 4 times negative 2, so that's going to be v to the negative 8. Now let's rewrite these negative powers into fractions, right? That's going to be 1 over 8 squared times 1 over u to the 8th power times 1 over v to the 8th power, right? See how we got those? Okay, now let's just do fraction multiplication, right? How do we multiply fractions? We multiply just the top parts, and then we multiply the bottom part, right? We multiply the numerators and then the denominator. What's 1 times 1 times 1? 1. So it'd be 1 over, okay, what's 8 squared? 8 times 8. 8 times 8 is 64, alright? And then times u to the 8, so just copy u to the 8, and then v to the 8. So your final answer should just be 1 over 64, u to the 8, v to the 8, like that. Alright, so the basic process is that whenever you have a negative power, okay, if you're not going to use the quotient rules, right, to bring, alright, if you have say a negative power in the top, we can bring it to the bottom and it becomes a positive power like that. Or vice versa, let's say if we had a negative power in the bottom, we can actually bring it to the top and it becomes a positive number. So the first thing I would do is check out the problem, check out the negative, alright, where the negatives are, and then all you have to do is just flip them, okay? So bring the top negatives to the bottom, and bring the bottom negatives to the top. And then you should just be able to combine like this, or cancel, or all those, you know, good stuff we like to do. And again here, alright, if we do the power rule, alright, you're going to get some negative exponents, right? All that means is that it's a fraction, right? So it's going to be 1 over a squared, and so forth. And all you do after this is just use multiplication of fractions, right? Multiply the top, then multiply the bottom, and then you get your answer.